Okay, so I want to go over just a couple things in class today. Maybe you were out for the AP exam and missed it, and I think it'll be helpful to go through some of these examples. And they're on page 84. I'm going to start with the two trig limits to memorize. I know we talked about these in class, but again, it might be good to see it again one more time, or maybe you were out for the AP exam. So this is on page 84. This is number 5, example 5, where it says evaluate the limit as x approaches 0 of sine x over x. And it's an identity that we need to know. And it's something that you could verify on your calculator. You could graph it. You could look at the table of values. And then next year in calculus, we're going to prove it that it's true using what's called a squeeze theorem. But the value here, the limit as x approaches 0 of sine x over x is equal to 1. So that's an identity that we have to, again, sort of file away is one of our facts in trig and in calculus. And we actually want to extend that even one step further. So what happens is the limit as x approaches 0 of, let's say, sine of, what if we had a coefficient in front of there, right? Like, let's say a times x over a coefficient b times x, right? So what happens if all of a sudden you start throwing different coefficients in front? Well, what ends up happening is that simply because as x is approaching 0 in both cases, it doesn't really matter what the a/b value is. It now approaches a value of that fraction a over b times 1, which is just a over b. So when you start seeing a ratio, for example, if I said, what's the limit as x approaches 0 of sine of 3x over 2x? So it doesn't matter what the 3 and the 2 that they're different. What matters is that you have a sine of some amount of x, so sine of x, and an x, right? And as long as you're approaching 0, that much of it will be approaching 1, and then 1 times 3 over 2, which is just 3 over 2. So we can just sort of jump right to that ratio to say that that's what the limit value is equal to 3 over 2. Just be cautious that you are, in fact, approaching 0, and then that's always true. Another example, let's say we have the limit as x approaches 0 of 2 sine of 5x over 4x. So, again, looking at this 5-to-4 ratio, and then just take it times 2. So it'd be 2 times 5-to-4, which is 10/4, or we could reduce that to 5/2. So that's a trig ratio that we should know, that the limit as x approaches 0 of sine of ax over bx is equal to a over b. Now, occasionally we might see sine squared, right? So here's another example that maybe that we didn't even actually look in class yet. So this is good to know. So here's another example. What happens if we have the limit as x approaches 0 of sine, let's say, squared of 5x over 3x squared? Well, we have to really think about what does that mean to be squaring sine. And what that means is that you take sine of 5x times itself. So I have a limit here, the limit as x approaches 0. And the sine squared, I'm just going to write as sine of 5x sine of 5x, and then 3x squared, I'm going to write 3x times x, because when it's 3x squared, it's just the x that's squared, nothing else. And now I have two limits. I've got this limit here, a 5-to-3 ratio as x approaches 0, and this limit here, a 5-to-1 ratio. So that's 25 over 3. So when you see sine squared, you note that you could just expand that. And the last thing about this example here that I like to look at, and then we'll look at our other trig identity, is that if you have the limit as x approaches 0 of the reciprocal, so maybe the sine function's down here, and the normal x is up here. And again, it could be a and b, or b and a, or whatever you want to call it, like maybe, or I'll call this one m, and this one n. Whatever those coefficients are, it doesn't matter. It's still going to be the ratio of m to n in the order that you see. Okay, so again, knowing that the limit as x approaches 0 of sine x over x is equal to 1, and then really kind of extrapolating, there it is, extrapolating that to any coefficient. The second trig identity that we need to know is the is the limit as x approaches 0 of 1 minus cosine x over x. And that limit, again, you could easily prove or verify on a graphing calculator or a table, that limit is equal to 0. And I forgot to mention in the first one too, and I'll mention it here, that remember, like if you try direct substitution, which you should always try, if you try to directly substitute 0 into that function, you're getting sine of 0 over 0, which is 0 over 0. And we said that 0 over 0, that represents a hole in the graph. But if we can't factor it, we have to have another way to deal with that hole. And so that's why knowing this identity is important. And the same thing is true here. If you directly substitute 0 and 0, well, cosine of 0 is 1, but then 1 minus 1 is 0, so you get 0 over 0. So again, there's that indeterminate form, that 0 over 0, and in this case, that limit value for this particular problem is 0. And you can extend that to say, well, what if the limit as x approaches 0 of 1 minus cosine of any amounts of x for a frequency, right? And it doesn't even have to be the same. It's not a problem. If you put that as an A, put that as a B, because the overall thing is 0, you're still going to get a value of 0. Okay. So those are some trig things that you should know. And I might as well, as long as we're talking trig, right? I can go off on a tangent on trig, which kind of is a pun intended because that's exactly what I look at. Often you see this one as well. The limit as x approaches 0 of tangent of x over x. Or if we extrapolate that, the limit as x approaches 0 of tangent of ax over bx. And again, if those coefficients are different, just kind of highlighting that. Well, the thing about tangent of x is that it can always be rewritten as sine x over cosine x. So this would be the limit as x approaches 0 of sine x over cosine of x, and then divide by x. And as you approach 0, right, as x approaches 0, the cosine function approaches 1. So that really becomes negligible. It doesn't really change anything. If that becomes a 1 and you divide it by sine, you still have, you divide it into sine, you still have the sine function. And so since cosine at 0 behaves like a 1, so this is sine of x divided by 1, which is sine x over x, we know that that limit is equal to 1. So this behaves just like tangent does, just like sine does, as long as you're approaching 0. So then that would be A to B. So again, like I said, that sometimes does come up, and so it's good to know those trig identities when it comes to limits.